Hello, welcome to this video. This is proportion lesson 3. So this is our lesson 3 on proportion, and in this lesson we are talking about inverse proportion. Now the first thing we are going to do is meaning of inverse proportion. Inverse proportion is the opposite of direct proportion. It is also called indirect proportion. Now, by definition, it is a type of proportion in which the increase of one quantity or value results to the decrease of the other proportional quantity or value. Now, in this proportion, you can see that the quantities just varies on opposite direction. That means when one quantity increases, as one quantity increases, it leads to the decrease of the corresponding or the proportional quantity. That's why it is inverse. So as one quantity is increasing, it's also what it's resulting in the decrease of the other quantity. Now let us see the examples of inverse or indirect proportion in real life. The first example can be seen in speed and time. Now speed and time. Now you know that more speed, the more you speed, then less time. So when you speed more, you spend less time to reaching your destination. So as your speed is increasing, the time you are going to spend will decrease. And when your speed decreases, the time we are going to spend for the journey increases. So that is opposite direction, inverse. And the second example is in rate of work done. In this case, what this means is that more people to work for you, the less time the work will be done. So the more people you have working for you, the more time the work will be done. So that is what? Indirect proportion. So as the people who do the work increases, the time that you tell them to do the work will decrease. And when the people decrease, the time will increase. That is inverse proportion. Also, we are going to have we're having number 3 says rate of consumption. This can be seen in the relationship between people and the rate of consumption. For example, more people to eat a particular food, the less time it takes the food to last. So when you have more people, the time it takes them to consume a particular food will decrease. So that is what inverse proportion. And the last is sharing. More people to share a particular thing, the less the share, less shares. So when you are sharing something by more people, the share will be less, and when the people decreases, the share will increase. So this is how inverse proportion plays in real life. And then we are going to have the formula for calculating our indirect proportion. The formula is saying inverse or indirect proportion is calculated by multiplying quantities with known proportional values and dividing by quantity with unknown proportional values. So in this case now, our D is going to be A times B. Before it in the direct proportion it was A over B. Now, so we are multiplying quantities whose values are known, and then we are dividing by the quantity that the proportional value is not known with unknown proportional value. That is going to be divided by C. So this is how the inverse proportion is done. So you multiply quantities with known proportional values and divide by the quantity with unknown proportional value. Now let's go ahead and solve some problem on this. Now we're going to solve some problems. That is the next thing we're going to do here is solving problems on indirect or inverse proportion. Now the first problem is coming from rate of work done, which I've already explained in the example. Now rate of work done. Let us see this question now. It says if 12 men cut a lawn in 4 days, in how many days can 8 men cut the same lawn if they work at the same rate? Now we're going to start with our formula. Formula for this proportion is what? Is indirect proportion. That is going to be A times B over C. And this A and B here is what? Is the quantities with known proportional value. That here you can see that 12 men cut the lawn in 4 days. So this is known. So it is known that 12 men can cut the lawn in 4 days. So these are the proportional value that is known now. So we are having that give us 12 men multiplied by 4 days. Then we are dividing by the quantity whose proportional value is not known. which is 8 men. So we don't know. They are asking how many days can 8 men cut the lawn. So we don't know how many days these 8 men cut the lawn. So this is unknown. That is going to be our C, which is going to be 8 men. So what do we do here now? At this point, we can just simply simplify. Of course, you know that men can go with men. So here, 4 into 4 is 1, and 4 into 8 is 2. So we are now left with 12 days over 2. That gives us 12 divided by 2, going to give us 6 days. So that means we're going to take 8 men. You're going to take these 8 men 6 days to cut the lawn. If it takes 12 men 4 days to cut it. So it's that when the men decreases to 8, the days it takes them to cut the lawn, the day has increased. As the men decrease, the day increase. That is inverse proportion. Now the second examples here talk about this example is from rate of food consumption. Food consumption. Sorry, I didn't write that, but this example is based on food consumption. And say 10 brothers have enough food for 6 days. How long will the same food last 16 brothers if they eat at the same rate? Of course, we write our formula. This is because this is inverse proportion. I'm going to write this equals to A times B over C. Now, let's solve it now. 10 brothers can have this food take them for 6 days. So these quantities are known that it takes 10 brothers 6 days to consume particular food. So we are going to be 10 brothers times 6 days. Then we're going to divide it by the quantity with unknown proportional value. Now let's say how long will the same food last 15 brothers? So the number of days it will take these 15 brothers is not known. That's going to be our C. This is going to be 15 borders. Now let us simplify. Border will go with border. So here we see that 15. Okay, let us do that. We are having 10 times 6 days over 15. So by the time we are going to simplify this, you know that 10 times 6 is going to give us 60 days over 15. And when we do 16 divided by 15 is going to give us 4. So that gives us 4 days. That means it's going to take 15 borders, 4 days. The food that take 10 borders for 6 days will take 15 borders for only 4 days because the number of borders has increased. And then lastly, we are going to have another problem to solve on this, and that is on rate of speed. This is going to be on rate of speed. Rate of speed. And it says a driver travel at a speed of 60 kilometers per hour and reach his destination in 2 hours. How long would he reach his destination if he traveled at a speed of 20 kilometers per hour? Now, we are going to write a formula which says D is equals to A times B over C, and we see from here that it takes the border what here the driver travel at the speed of 60 kilometers per hour and reach the destination in 2 hours. So the speed here now, that is 60 kilometers per hour multiplied by 2 hours. Then the one that is not known now is how far he will travel in 20 kilometers per hour. So we are going to divide it by 20 kilometers per hour. Of course, this km per hour cancel this km per hour, and 0 cancel 0. So we're now left with 6 times 2 hours, which is going to give us 12 hours divided by 2. That gives us 6 hours. So that means that if the driver travel at the speed of 20 kilometers per hour, he's going to arrive in not days, it's going to be 2 hours. It's going to be arrive in 6 hours. So thank you for watching this video, and subscribe to this channel for further video, and turn on your notification bell. And other videos on proportion, check the description of this video for other videos on proportion. Thank you very much.